Welcome to Professor Uttam's video. This is a virtual power plant raising steam and a turbine system. Now you can look at this water tube boiler system. You will find section is a this is a stack where flue gas goes out. This is your economizer section. This is a boiler section with a mud drum for blowdown of heavy water, and then followed by superheater, and then the exhausted steam which goes to either to the pressure reducing station to the atmosphere or to the turbine as the steam quality approves at a pressure of 60 to 65 kg per centimeter square and temperatures about 400 degrees centigrade. Now we'll start with manual start. At the beginning we have a water circulation. This you can see here the water is deaerated with the help of steam initially. So deaerated air is pumped by high pressure pump through the economizer tube bundles, and then this water goes to this boiler, and then finally it fills the superheater, and from this superheater bundle it goes back to this water cooler, and then is a steam recovery section where the steam condensators are collected and returned back to the pump. And initially this water circulation is started for testing the leakage as well as for the stability. And this in the top you will see the control panel which shows the feed pump pressure and the flow rate, followed by the economizer tubes where pressure and temperature of water or steam is given, and the boiler drum, the saturated pressure and temperature shown, and the level of the drum is also controlled where you will see certain 50 or 40% level is maintained in order to avoid steam leakage down the mud drum. And then the superheater where the temperature and pressure is more than 400 degrees centigrade, and pressure is 65 to 70 kg per centimeter square. Initially, the startup we will have this ID fan and FB fan both are started, where the ID fan sucks this flue gas from the top. This is damper. When required time, this pressure is adjusted and exhausted to the atmosphere, and flue gas is sucked by this ID pump or induced draft fan, and then it goes to the preheater where atmospheric air is forced draft fan which forces the atmospheric air to the preheater so that the temperature of this air gets heated by exchanging heat with the hot flue gas, and this hot preheated air is then used for burning purposes in these burners located here. And we'll see that ID fan and FD fan has required circulation is around 40 millimeter of water gauge, and FD fan for the 100 millimeter water gauge. And now it is exit temperature is 30 degrees centigrade because there is no heating. Now we'll start the burner. We write the torch burners. Here the burners you can see is glowing the red, and as it is heating, hot gas is passing through the intersection and it's going through the stack finally, and it is sucked by the ID fan. Now you can see that flue gas temperature is also rising, and the boiler drum here you will find that water is vaporizing continuously. And look into this control room, this control feed pressure and flow rate, economizer pressure and temperature of the steam, and you will see that boiler pressure and temperature corresponding level is maintained. And here you will find the superheater having a pressure of around 62 kg per centimeter square, and temperature is 405 degrees centigrade. It is nearly about superheated steam which is desirable for making the turbine to start. And we can see that there is a startup now for the turbine. When it's ready, you just press this button. You will see that exhaust steam has been closed, and it is totally going to the turbine, which rotates the turbine, and electricity is generated. And even this turbine shaft is connected with the alternator and a generator for necessary electricity generation, which is not in the scope of this simulator. Now this steam which is condensed are returned to this cooling water, cooling water with the help of this condenser, and then this is a steam recovery section where all these condensers are mostly returned back and recycled, because it's a DM water which is valuable as a demineralized water. So this is a general description of a water tube boiler. As I showed you, it is here gas or liquid firing or combination firing is possible. So a maximum temperature occurs in the superheater. Now, in case you want to shut down, initially for this turbine has to be shut down. So if turbine is stopped by just closing the steam valve, and the steam is exhausted to the atmosphere. Where the steam service is continuous, it is producing steam and water pumping is done. Now if you want to start the turbine, if there is something wrong in the turbine and you have to stop it, you can do it, and you can start it up when it's ready. Again, you can see that the steam valve is open and the turbine is started. Now in the shutdown procedure, you have to shut down the turbine first, and turbine is stopped, and you can look at this steam production is still on. Now you want to shut down the furnace. Now you shut down the furnace, that is flue gas is been stopped here, so there's no fuel, no burning, so the flame is absent. Now it is water is flowing inside this system and cooling the drum as well as the hot tube sections, and finally it is cooled down, and you have to wait till it is totally cooled. But you cannot stop this IDNA fan because this hot gas is not yet cooled down. Now it is around 40 degrees centigrade, and it will be cooled down now almost. So you can stop the ID fan and FD fan, and then you can drain the water after checking up this leakage or necessary testing of the boiler, and then you have to wait for some time. All the water will be drained out, and the entire system will be taken for maintenance work for this for the boiler drum inspection as well as for mud drum and the valve checking for the drain out. So this is simplified explanation of a steam heated boiler system. I mean water tube boiler where steam is used for the driving force for the turbine. Thank you very much for observing the video.